Okay, in this example, we are going to solve a very fun optimization problem. Suppose you are going to play the game called Clash of Clans. So in this game, you have to train your troops to fight against other clans, okay? And each of your, let's say, soldiers have different characteristics. They have different maximum hit points, or this example is referring to the Clash of Clans game. We are going to model it as a linear kind of programming. If you are familiar with this game, you do have different troops, and each of them has different characteristics. The amount of hit points it can tolerate, the amount of damage it can cause, and the training time is different for every single troop. And sometimes you want to attack your enemies and you want to have maximum hit points, or you might want to maximize the attacking capabilities, and you want to do it at the minimum training time. Okay, so depending on how much you want to tolerate damage, or how much damage you can cause, or how long does it take to train your troop, or how much cost does it create to train your troop, your strategy for training the troop is different. So as I said, depending on your troop, they have different requirements and different costs. So some of them take more time to train and they use more Elixir, okay? And so in order to find out the best strategy to train your troop, you can create an optimization problem and solve it for yourself. So as I said, there are multiple number of troops that you can train, and each of them has its own characteristics. So in order to do that, the attack capabilities of each troop is stored in a parameter called attack, or heat, or time of training, and xi is telling GAMS how many of each troop you are going to choose. So obviously you have to choose the integer kind of variables to model that properly, and also the housing of the camps are limited. So xi multiplied by housing summation should be less than the camp capacity, and also based on the availability of your Elixir, your training costs should be limited. Okay, so for solving this model, you do need to have the different characteristics associated with each troop. For example, in this dat file, you can see that different troops here, you can see them here, have different characteristics: housing space, damage they can create, training cost in using red Elixir or dark Elixir is different, the amount of hit point they can tolerate is different, training time is different for all of them, and the capacity of your camp, it should be specified here, and the availability of your red or dark Elixir is also specified in this Python code. Okay, so let's have a look at the Python code itself. So first of all, as usual, we have to import all the required packages, and then we have to declare the parameters that we are going to use. For example, set I is representing every troop you have, and also these parameters like housing space, damage, training cost red, training cost dark, hit point, training time, camp capacity, and also red Elixir availability and dark Elixir availability should be specified, and also how many of each troop you have to train should be defined by a variable called x, and that X, for example, since your camp has 280, I think, capacity, so the number of troops cannot be more than that, and also they are coming from non-negative integers, so positive integers, and initialize them with 0, and also total attack capability, total hit point, and also the time required for training those troops is also specified. So there are some rules or some constraints that are defined here. I will explain some of them for you. For example, the amount of damage, total attack, is xi multiplied by damage I summation over all I in the model. And also the total housing space should be less than your capacity of your camp. And also the required red elixir should be less than your available red elixir. The same for dark elixir. And also the total hit point is defined over hit point multiplied by xi summation over I. And also finally the training time is defined as follows. So we do have 3 objective functions. This is the tricky point, okay? So in Pyomo, you can't have more than 1 objective function, okay? So that's fine if you define 3 objectives. It doesn't depend what name you choose here. This is the keyword which is important here. But you can define them, but you can't have them all active in your model. So you specify your solver. I use GLPK because it's linear integer programming. And you have to deactivate 2 of them and just keep 1 of them. So I deactivate objective 2 and 3. I have activated objective 1. It's not really necessary for the first time because it's already activated. And then create instance using the data I already showed you and solve the results. It gives you the final solutions. So it can tell you that if you want to maximize the damage, you have to put all your efforts in training wizards, okay, and 1 goblin. Or, for example, if you want to make the objective number 2 activated, let's have a look. What was the objective 2? Objective 2 is total hit point, okay? So if you want to maximize your hit point, you have to train giants, okay? And that's it. So you can change your objective functions, you can change your availability of the red elixir or dark elixir and see what will happen to your capability of the troops. Thank you very much.